channel Study of Science with Rahul Kesherwani. Today I will start the group 16 elements, which is the part of P block elements. As you know, in the group 16 elements included the following elements. Let's see. There is the elements which is present in group 16 are oxygen, sulfur, selenium, tellurium and polonium. O indicates oxygen, S indicates sulfur, Se indicates selenium, Pe indicates tellurium and Po indicates polonium. Atomic number of these elements are 8, 16, 34, 52 and electronic configuration of these elements. Before starting the electronic configuration, these are non-metal. Sulfur is also non-metal. Selenium and tellurium both are metalloid. And polonium is a metal which is radioactive metals. Basically, oxygen, sulfur, selenium and tellurium, they are called chalcogens because these elements are responsible for the ore forming elements. Chalcogens means ore forming elements. Means basically the ore formation of various elements is basically due to the reaction which these elements, that is in oxide form, sulfide form, selenium form and tellurium form. So they are called chalcogens, right? Now we discuss the electronic configuration of these elements. If we write the electronic configuration of these elements, then 1s2, 2s2, 2p4, 1s2, 2s2, 2p, 6, 3s2, 3p4. Similarly, 4s2, 4p4, 5s2, 5p4 and for this, that is 6s2, 6p4. So the outermost electronic configuration of these elements are outermost electronic configuration equal to ns2 np4 and the value of n, that is the principal quantum number, which is from 2 to 6. So this is the outermost electronic configuration of these elements, right? Now we discuss about the some traits of physical and atomic properties. Physical properties. As you know, oxygen, sulfur, selenium, tellurium and polonium having atomic number 8, 16, 34, 52 and 84. We discussed the first physical properties, that is the atomic radii. These elements are smaller than group 15 elements due to higher nuclear charge. Means group 16 elements are smaller in size as compared with the group 15 elements. Group 15 is larger in size as compared to the group 16. Because when we move from left to right, there will be increase in the nuclear charge. That's why the size of these elements decreases as compared to the group 15. Now, in case of group, atomic size increases down the group because increase in number of cells. Means when we move from top to bottom, then there is increase in number of cells. That's why the size of these elements increases down the group. Second physical properties is ionization enthalpy. The first ionization enthalpy of group 16 elements are unexpectedly lower as compared to group 15. Because in case of group 15 there is the symmetrical electron distribution are present. Due to symmetrical electron distribution in group 15. As in case of nitrogen and oxygen, that is 1s2, 2s2, 2p3. But in case of oxygen, that is 1s2, 2s2, 2p4. Here P have 1, 2 and 3 electron which is in symmetrical form. But in case of oxygen, there is the 4 electron, 1, 2, 3 and 4. So this is not in symmetrical form. So that's why there the first ionization enthalpy of oxygen is lower as compared to the nitrogen. But after losing 1 electron, the oxygen group 16 elements got the symmetrical electron distribution. So the second ionization enthalpy is higher as compared to group 15 elements, right? Because after losing 1 electron, then the oxygen got the symmetrical electronic configuration. That's why they have higher ionization enthalpy, right? Now, in case of in group, when we move from top to bottom, then ionization enthalpy decreases due to increase in atomic size and shielding effect, right? What is shielding effect, which is discussed in the previous video, which is the group 15 elements. So in the group, when we move from top to bottom, then the ionization enthalpy decreases due to increase in atomic size as well as increase in shielding effect. Now we discuss the third physical properties, that is the oxidation state. The oxidation state of these elements shows basically two types of oxidation state: negative oxidation state and positive oxidation state. Oxygen have very different properties as compared to the other elements due to the absence of due to absence of d orbitals as well as the small size of oxygen. As in case of oxygen, there is the oxidation state is -2, -1 and 0. In case of oxide, that is in case of H2O, that is in oxide form, the oxidation state of oxygen is -2. As in case of -1, that is in peroxide form, that is H2O2. In case of 0, that is in dioxygen, as in trioxygen, that is oxygen and ozone. So oxygen shows negative oxidation state as -2, -1 and 0. But positive oxidation state is shown as +2, +4 and +6. As seen here, oxygen, that is 8, 1s2, 2s2 and 2p4. As in case of 2s, that is 2 electron and p have 4 electron, 1, 2, 3 and 4. There is no vacant orbitals which is present in the higher state, which is required higher amount of energy to goes these electrons into the next higher state, that is in 3s. So there is only 2 unpaired electrons. That's why the oxygen shows +2 oxidation state. But in case of sulfur, that is 16, 1s2, 2s2, 2p6, 3s2 and 3p4 and 3d0. That is 3s2, 2 electron, that is 3p4, 1, 2, 3 and 4, and 3d are vacant, 1, 2, 3, 4 and 5. So this shows in ground state +2 oxidation state, +2 oxidation state. But when it get in first excited state, then this electron goes into the vacant d orbital, and then this shows 1, 2, 3 and 1, that is +4 oxidation state. And when sulfur goes in the second excited state, then it shows 1 electron is here and goes to the next that is 1, 2, 3, 4, 5 and 6, that is +6 oxidation state. So basically these elements shows the positive oxidation state, but in case of oxygen there is the high electronegativity, that is they have high electronegativity to obtain or gain electron. That's why they show the negative oxidation state. But in case of sulfur, selenium, tellurium and polonium, there is the +2, +4 and +6 oxidation state, right? The +6 oxidation state, stability of +6 oxidation state decreases when we move from top to bottom. Means +6 oxidation state in case of sulfur is more stable as compared to polonium due to inert pair effect. What is inert pair effect? That is the s electron is not participated in the formation of bond. That is the inert pair effect. That's why they show the more stable in case of +6 oxidation state in case of sulfur as compared to the polonium. Right? Now the next physical properties of these elements. Next physical properties is metallic character. Group 16 elements are less metallic character as compared to group 15 due to high ionization enthalpy. But when we move from top to bottom, the metallic character increases. But when we move from top to bottom, then metallic character increases. Right? Now the next physical property is electronegativity. Group 16 elements are higher electronegative as compared to group 15, and oxygen is the second most electronegative element, and first one is the fluorine. So this is the 5 physical properties. Now the next physical properties. Physical properties is melting point, boiling point, and density. These are increases down the group, means up to tellurium, because polonium is radioactive element due to increase in atomic size. So when atomic size increases, the van der Waals force of attraction is also increases. So van der Waals force of attraction increases. That's why the melting point, boiling point, and densities of these elements increases. Right? Now the next physical properties is electron gain enthalpy. The electron gain enthalpy of these elements, that is group 16 elements, are large negative electron gain enthalpy. Group 16 have large negative electron gain enthalpy after the halogen, that is group 17, because they have property to accept two electrons and get noble gas configuration, and oxygen have least negative electron gain enthalpy due to a small in size, and the value for oxygen is minus 141 kilojoule per mole. In case of sulfur, there is the minus 200 kilojoule per mole. So these elements have largest negative gain electron enthalpy as compared to the halogen, because they require two electrons to obtain the noble gas configuration. Right? Now the next property is, that is elemental form. This is elemental state. As oxygen is present in diatomic, oxygen is present as diatomic, that is O2, as gas at room temperature, because a small size it form p-pi bond. That's why the oxygen is present in the at room temperature, due to formation of p-pi bond. But other elements of this group not form p-pi bond. That's why they are not exist as diatomic, but they exist as octatomic as formation with single bond, like as S8, Se8, Te8, and they have some structure, and they have puckered ring structure. Now what is the puckered ring? As acid form, that is puckered ring form. Like this. And sulfur have 107 degree bond angle, and the bond length is sulfur between sulfur is 201 centimeter. But sulfur and other elements, sulfur, selenium, tellurium and polonium, form the p-pi and d-pi multiple bonds. Sulfur, selenium, tellurium form p-pi and d-pi multiple bonds due to presence of the orbital. So these are the physical properties regarding with the group 16 elements. Thank you for watching this video. Like this video and don't forget to share this video. Thank you very much.